In this video, we're going to look at example 1, where we use zeros to graph a polynomial function. And we're asked, what are the zeros of f of x equals x times x minus 4 times x plus 3, and then we're asked to graph the function. So looking at this little statement here, a zero of a polynomial function is a value for which the function is equal to 0. And by the zero product property, which we've covered a while ago, the zeros of the function are, and we're going to take each of these three pieces. So we can say x is equal to 0, x minus 4 is equal to 0, and x plus 3 is equal to 0. Well, this one's already set up for us, so we could say x is equal to 0. Here we could just add 4, so 4 would be a 0, and here we're going to subtract 3. So our three zeros, let me just clean that one up, are 0, 4, and negative 3, which means that those break up, or yeah, they kind of break up they create a number line, and they break things into intervals. So if I listed those numbers, I'd have negative 3 here, 0, and 4. And I now have 4 intervals here. Right, and if I was to graph this, kind of be 4 different things that could potentially happen there. My graph might look something, if this was a graph, maybe it looks like this, maybe it winds up looking like this. Could really be anything. So we need to figure out, all right, what would that graph look like? Now, there are definitely more efficient ways, we'll say, to do this, but we're going to look at a method where you can do this by hand. All right, so the first thing I'm going to do is I'm going to list my 4 intervals. Just make a little chart here. All right, and let's send it across. So my first interval would be the numbers that are less than 0, right? So we'd have x is less than, sorry, not 0, negative 3. My second interval, I'm going to just shade all these in so we can color code these. My second interval would be from negative 3 to 0. Then I would have from 0 to 4. And then finally, when x is greater than 4. Right, so those are the 4 intervals that'll wind up on my graph. Now from there, what I can do is I can look at the signs of each piece. All right, and this is where this gets a little tricky, so you have to be careful when you're setting this up. I did not want to erase that. So we have each of these. I gotta fix this chart here. Right, and this first piece here is just x. So we're going back up here to these pieces. All right, and these pieces are going to come from there. So we have x minus 4, and x plus 3. And we want to know what happens on each part of those intervals, we'll say. All right, so if I'm looking at, and again, this is where this gets a little complicated when you're doing this by hand. There are clearly more efficient ways, but for this example, this is how we're going to do it. You're going to look at, I keep erasing, you're going to look at x within this interval. All right, well, what do we know about x on that interval that's highlighted in orange there? If x is less than negative 3, we know that x is always negative. All right, no matter what happens, x has to be negative. Now, if I take that same x value and I plug it in here, all right, what do we know about x from the interval negative 3 to 0? Again, as long as x is in between negative 3 and 0, it has to be negative. Now looking at the x value here, so again, we're comparing x. X is between 0 and 4, so that tells me it has to be positive. And then finally, x is greater than 4. Well, obviously anything greater than 4 has to be positive. All right, so that's how you would fill out the chart. You don't have to do the same thing now with this x minus 4. All right, so if I take this piece here, if x is always negative, because it's less than negative 3, and I'm subtracting 4 from that value, it's going to make that number smaller. So if I have a number that's already negative, and I'm making it smaller, well, it's going to have to be negative. and then you again move through this chart. So here we take x minus 4, plug it in here. Well, between -3 and 0, x is always going to be negative, and if I subtract that 4, I will continue to have a negative number. Now we look at x minus 4 in this third interval. So 0 to 4 is going to be positive, but any of those numbers between 0 and 4, if I subtract 4 from them, they're going to become negative. Right, so be careful with that one, particularly ones like that where that number is part of your interval. And then finally, let's change colors. This x minus 4, if I plug this in here, right, if x is always greater than 4, it's positive. Any number that's greater than 4, if I subtract 4 from it, I still have a positive number. I apologize for this because I know this does get a little annoying, it does get tedious. There are way better ways to do this, but for this method, we're doing this by hand. And then finally, let's do the x plus 3 column. So this first group, if I take any number that's less than -3 and I add 3 to it, it's still going to be negative. Some of them will be just barely, but they still will be negative. If I take x plus 3, plug it in here. Now, any numbers between -3 and 0, if I add 3 to any one of those numbers, so if I pick, again, any of them, it's going to wind up positive. Right? So if I'm adding 3 to a number that is larger than -3, it will be positive. That x plus 3 here, well, between 0 and 4, we're already positive and we're adding to it, so that is going to stay a positive number. And then finally, this one here, if I'm adding 3 to a number that is already greater than 4, that is also going to be a positive number. All right. Just when we thought we were done, we actually need to find the product of these. So what that means is I am looking to, what color do I want to use here? I'm looking to multiply these three. All right, so if I was to multiply a negative times a negative times a negative, that is going to give me a negative number. Look at the next row. A negative times a negative is positive, times another positive would be positive. So what we're doing is we're multiplying these three signs to see what type of sign our product would be, all right, whether it's positive or negative. Next, we're looking at these. Positive times negative is negative, and negative times positive would be negative. And then all positives, positive times positive times positive, we know is going to be positive. So what that tells us, on the interval x is less than -3, we're going to have a negative number. -3 to 0 is going to be positive, 0 to 4 will be negative, and x is greater than 4 will be positive. So we can finally sketch our graph. So I'm going to do this here. I'm going to have a -3, right? We're going to have our origin there, and then 4. This doesn't have to be perfect. This x is less than -3 would be down here. I know that I have negative as part of my graph, so that graph is going to go down this way some way. Again, it might be some type of curve. We don't know exactly what it's going to look like, but it's going to be decreasing. It'll be below the x-axis. Then, on the interval -3 to 0, we know that that is positive, so that's going to be above the x-axis. Then from 0 to 4, we know that is going to be negative. I forgot to highlight one thing here. We know that that will be negative, so I can draw some kind of sketch here. And again, we don't know how sharp that curve is. We don't know where what its max or min might be, but right now we're just looking to draw sketches. And then finally, when x is greater than 4, we know that this graph is positive, so this would be above the x-axis, and that would be the sketch of our graph. Now you could always use a graphing calculator or some kind of online application to check your graph and make sure that your sketch is pretty accurate, but we're really just looking to see where it crosses the x-axis, and because those zeros, let's highlight here, these zeros are where our graph should cross our x-axis. And then using this chart down here, that helped us figure out whether each interval was positive or negative. One more time, I do apologize for this tedious process, but for this type of example, they're really looking for you to draw this by hand without any resources, without any graphing calculators or online applications or anything like that. Give the tryout problems a go. Part A and B, you're actually going to have to factor those first. Our example was already factored. Part 1A and 1B, you are going to have to factor before you can find the zeros. Good luck.